Bismillahirrahmanirrahim. This is the video on chapter 2.3, which is the addition rules for probability. Before we do the calculation part, you have to know several concepts in the third subtopic. The first one is you have to know what is A union B. A union B is the event that A or B or both A and B occur. So if you have the word or in the question, that one represent union symbol. So how can you illustrate in the Venn diagram form? This is the Venn diagram for A union B, where you have the shaded area is everything inside the circle. The second one is A intersection of B. A intersect B. That is both event A and B occur. So the shaded area is only the intersection part. This is the Venn diagram. Illustrate A intersect B. And you have the formula for the addition rule, which is PA union B is equal to probability of event A plus probability of event B minus probability of event A intersect B. This one we call as the formula of the addition rule. And then the third one is the mutually exclusive events. It is the events that cannot occur at the same time or they have no common outcomes. For example, let's say you are rolling a die. The first event is getting number greater than 3 and the second event is getting number less than 3. So the outcome for event A is you might have 4, 5, 4, 6 greater than 3. The outcome for event B is you are having number less than 3, which is 1 and 2 only. So if you look at these two outcomes, you don't have any common value. This is the example of the mutually exclusive events. So since you don't have any intersection part, so we call that intersection is equivalent to 0 set. And then what happened to the addition rule formula just now? You don't have any intersection event. So your formula will be PA union B is equal to PA plus PB only without the intersection of A and B. Why? Because your A intersect B is equal to 0. So how can you represent the Venn diagram? This is the Venn diagram for the mutually exclusive events. You must draw a separate circle for event A and event B since you don't have any intersection events. If let's say you are having more than 2 events for the mutually exclusive, your formula will be PA union B union C is equal to PA plus PB plus PC. You don't have any intersection part. That is the only concept in 2.3. Okay, let's look at the example. Example number 2. A furniture store decides to select a month for its annual sale. Find the probability that it will be April or May. Assume that all months have equal probability of being selected. Equal probability here means you have total of 12 months. So every month will have the same probability, which is 1 over by 12. So how can you symbolize this question? You have to find probability of having April. Let's say Madam symbolize April as capital A. Or you have the word or here, which is represent union symbol. Or May. Okay. Capital M is represent the month of May. So how can you calculate the probability? Just use the addition rule formula, which is you have P April plus P May. Do you have the intersection event between April and May? Intersection means you want to pick 1 month, exactly 1 month. Is there a possibility that the month that you take is both April and May at the same time? No, right? You cannot have 2 months at the same time. You pick 1 month only at one time. So you don't have any intersection event between April and May. So this is the example of mutually exclusive events actually. So to find probability of April, you will have 1 over 12 plus probability of me also 1 over 12. So add on both value, you have 2 over by 12. Simplify further, 1 over by 6. That is your answer. Okay, move to example number 3. At a particular school with 200 male students, 58 play football, 40 play basketball, and 8 play bowls. What is the probability that a randomly selected male student plays neither sport? Plays neither sport. That is the keyword, neither sport. Okay, let's see madam represent the situation in the Venn diagram form. So you have from the question, 8 male students play both games, which is the 8 male will be here. And the question also give you 58 of them play football. So how many playing football only, which is this area? 58 minus by 8. So you have 50 male students play football only. Okay. And then you are having 40 play basketball. And how many of them play basketball only? So you are having 40 minus by 8, which is 32. Okay. So total is 200. So where is the rest of the students? So the rest is 200 minus by 50 minus by 8 minus by 32. Then you have 110. So where is 110? Outside the circle. Yeah. So you have here 110, which is that students play neither sport. Okay. So that is the question want you to have. So how can you calculate play neither sport? You can symbolize as not playing football and also not playing basketball. That is the symbol for that question. Plays neither sport. Or you can have the symbol of football, union, basketball. Now, where is football, union, basketball? The things inside the circle. And then you want outside only. Okay. So just use the complement of everything. That is another symbol that you can have to represent the question. Okay. So what is your answer just now? 110 over by 200. And then simplify further. You have 11 over 20. That is your answer for example 3.